Attribution of recent climate change is the effort to scientifically ascertain mechanisms responsible for recent climate changes on Earth, commonly known as global warming. The effort has focused on changes observed during the period of instrumental temperature record, when records are most reliable, particularly in the last 50 years, when human activity has grown fastest and observations of the troposphere have become available. The dominant mechanisms are anthropogenic, i.e., the result of human activity. They are increasing atmospheric concentrations of greenhouse gases, global changes to land surface such as deforestation, increasing atmospheric concentrations of aerosols. There are also natural mechanisms for variation including climate oscillations, changes in solar activity, and volcanic activity. According to the Intergovernmental Panel on Climate Change, it is extremely likely that human influence was the dominant cause of global warming between 1951 and 2010. The IPCC defines extremely likely as indicating a probability of 95 to 100%, based on an expert assessment of all the available evidence. Multiple lines of evidence support attribution of recent climate change to human activities. A basic physical understanding of the climate system. Greenhouse gas concentrations have increased and the warming properties are well established. Historical estimates of past climate changes suggest that the recent changes in global surface temperature are unusual. Computer-based climate models are unable to replicate the observed warming unless human greenhouse gas emissions are included. Natural forces alone cannot explain the observed warming. The IPCC's attribution of recent global warming to human activities is a view shared by most scientists, and is also supported by 196 other scientific organizations worldwide. Background. This section introduced some concepts in climate science that are used in the following sections. Factors affecting Earth's climate can be broken down into feedbacks and forcings. A forcing is something that is imposed externally on the climate system. External forcings include natural phenomena such as volcanic eruptions and variations in the sun's output. Human activities can also impose forcings, for example, through changing the composition of the atmosphere. Radiative forcing is a measure of how various factors alter the energy balance of the Earth's atmosphere. A positive radiative forcing will tend to increase the energy of the Earth atmosphere system, leading to a warming of the system. Between the start of the Industrial Revolution in 1750 and the year 2005, the increase in the atmospheric concentration of carbon dioxide led to a positive radiative forcing, averaged over the Earth's surface area, of about 1.66 watts per square meter. Climate feedbacks can either amplify or dampen the response of the climate to a given forcing. There are many feedback mechanisms in the climate system that can either amplify or diminish the effects of a change in climate forcing. Aspects of the climate system will show variation in response to changes in forcings. In the absence of forcings imposed on it, the climate system will still show internal variability. This internal variability is a result of complex interactions between components of the climate system, such as the coupling between the atmosphere and ocean. An example of internal variability is the El Niño Southern Oscillation. Detection versus attribution. Detection and attribution of climate signals, as well as its common sense meaning, has a more precise definition within the climate change literature as expressed by the IPCC. Detection of a climate signal does not always imply significant attribution. The IPCC's fourth assessment report says it is extremely likely that human activities have exerted substantial net warming influence on climate. since 1750, where extremely likely indicates a probability greater than 95%. Detection of a signal requires demonstrating that an observed change is statistically significantly different from that which can be explained by natural internal variability. Attribution requires demonstrating that a signal is unlikely to be due entirely to internal variability, consistent with the estimated responses to the given combination of anthropogenic and natural forcing, not consistent with alternative, physically plausible explanations of recent climate change that exclude important elements of the given combination of forcings. Key attributions. Greenhouse gases. Carbon dioxide is the primary greenhouse gas that is contributing to recent climate change. CO2 is absorbed and emitted naturally as part of the carbon cycle, through animal and plant respiration, volcanic eruptions, and ocean-atmosphere exchange. Human activities, such as the burning of fossil fuels and changes in land use, release large amounts of carbon to the atmosphere, causing CO2 concentrations in the atmosphere to rise. The high-accuracy measurements of atmospheric CO2 concentration, initiated by Charles David Keeling in 1958, constitute the master time series documenting the changing composition of the atmosphere. These data have iconic status in climate change science as evidence of the effect of human activities on the chemical composition of the global atmosphere. Along with CO2, methane and nitrous oxide are also major forcing contributors to the greenhouse effect. The Kyoto Protocol lists these together with hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride, which are entirely artificial gases, which also contribute to radiative forcing in the atmosphere. The chart at right attributes anthropogenic greenhouse gas emissions to 8 main economic sectors, of which the largest contributors are power stations, industrial processes, transportation fuels, and agricultural byproducts. Water vapor. Water vapor is the most abundant greenhouse gas and also the most important in terms of its contribution to the natural greenhouse effect. Despite having a short atmospheric lifetime, some human activities can influence local water vapor levels. However, on a global scale, the concentration of water vapor is controlled by temperature, which influences overall rates of evaporation and precipitation. Therefore, the global concentration of water vapor is not substantially affected by direct human emissions. Land use. Climate change is attributed to land use for 2 main reasons. Between 1750 and 2007, about 2/3 of anthropogenic CO2 emissions were produced from burning fossil fuels, and about 1/3 of emissions from changes in land use, primarily deforestation. Deforestation both reduces the amount of carbon dioxide absorbed by deforested regions and releases greenhouse gases directly, together with aerosols, through biomass burning that frequently accompanies it. A second reason that climate change has been attributed to land use is that the terrestrial albedo is often altered by use, which leads to radiative forcing. This effect is more significant locally than globally. Livestock and land use. Worldwide, livestock production occupies 70% of all land used for agriculture, or 30% of the ice-free land surface of the Earth. More than 18% of anthropogenic greenhouse gas emissions are attributed to livestock and livestock-related activities such as deforestation and, increasingly, fuel-intensive farming practices. Specific attributions to the livestock sector include 9% of global anthropogenic carbon dioxide emissions, 35 to 40% of global anthropogenic methane emissions, 64% of global anthropogenic nitrous oxide emissions, chiefly due to fertilizer use. Aerosols. With virtual certainty, scientific consensus has attributed various forms of climate change, chiefly cooling effects, to aerosols, which are small particles or droplets suspended in the atmosphere. Key sources to which anthropogenic aerosols are attributed include biomass burning such as slash-and-burn deforestation. Aerosols produced are primarily black carbon. Industrial air pollution, which produces soot and airborne sulfates, nitrates, and ammonium. Dust produced by land use effects such as desertification. Attribution of 20th-century climate change. Over the past 150 years, human activities have released increasing quantities of greenhouse gases into the atmosphere. This has led to increases in mean global temperature, or global warming. Other human effects are relevant. For example, sulfate aerosols are believed to have a cooling effect. Natural factors also contribute. According to the historical temperature record of the last century, the Earth's near-surface air temperature has risen around 0.74 plus or minus 0.18 degrees Celsius. A historically important question in climate change research has regarded the relative importance of human activity in non-anthropogenic causes. During the period of instrumental record, in the 1995 Second Assessment Report, the IPCC made the widely quoted statement that the balance of evidence suggests a discernible human influence on global climate. The phrase balance of evidence suggested the common law standard of proof required in civil as opposed to criminal courts, not as high as beyond reasonable doubt. In 2001, the Third Assessment Report refined this, saying, "There is new and stronger evidence that most of the warming observed over the last 50 years is attributable to human activities." The 2007 Fourth Assessment Report strengthened this finding. Anthropogenic warming of the climate system is widespread and can be detected in temperature observations taken at the surface, in the free atmosphere, and in the oceans. Evidence of the effect of external influences, both anthropogenic and natural, on the climate system has continued to accumulate since the TAR. Other findings of the IPCC Fourth Assessment Report include: it is extremely unlikely that the global pattern of warming during the past half-century can be explained without external forcing, and very unlikely that it is due to known natural external causes alone. The warming occurred in both the ocean and the atmosphere and took place at a time when natural external forcing factors would likely have produced cooling. From new estimates of the combined anthropogenic forcing due to greenhouse gases, aerosols, and land surface changes, it is extremely likely that human activities have exerted substantial net warming influence on climate since 1750. It is virtually certain that anthropogenic aerosols produce a net negative radiative forcing with a greater magnitude in the northern hemisphere than in the southern hemisphere. Over the past 5 decades there has been a global warming of approximately 0.65 degrees Celsius at the Earth's surface. Among the possible factors that could produce changes in global mean temperature are internal variability of the climate system, external forcing, an increase in concentration of greenhouse gases, or any combination of these. Current studies indicate that the increase in greenhouse gases, most notably CO2, is mostly responsible for the observed warming. Evidence for this conclusion includes estimates of internal variability from climate models, and reconstructions of past temperatures, indicate that the warming is unlikely to be entirely natural. Climate models forced by natural factors and increased greenhouse gases and aerosols reproduce the observed global temperature changes. Those forced by natural factors alone do not. Fingerprint methods indicate indicate that the pattern of change is closer to that expected from greenhouse gas-forced change than from natural change. The plateau in warming from the 1940s to 1960s can be attributed largely to sulfate aerosol cooling. Details on attribution. Recent scientific assessments find that most of the warming of the Earth's surface over the past 50 years has been caused by human activities. This conclusion rests on multiple lines of evidence, like the warming signal that has gradually emerged from the noise of natural climate variability. The scientific evidence for human influence on global climate has accumulated over the past several decades from many hundreds of studies. No single study is a smoking gun, nor has any single study or combination of studies undermined a large body of evidence supporting the conclusion that human activity is the primary driver of recent warming. The first line of evidence is based on a physical understanding of how greenhouse gases trap heat, how the climate system responds to increases in greenhouse gases, and how other human and natural factors influence climate. The second line of evidence is from indirect estimates of climate changes over the last 1,000 to 2,000 years. These records are obtained from living things and the remains and from physical quantities, which change in measurable ways as climate changes. The lesson from these data is that global surface temperatures over the last several decades are clearly unusual, in that they were higher than at any time during at least the past 400 years. For the Northern Hemisphere, a recent temperature rise is clearly unusual in at least the last 1,000 years. The third line of evidence is based on the broad, qualitative consistency between observed changes in climate and the computer model simulations of how climate would be expected to change in response to human activities. For example, when climate models are run with historical increases in greenhouse gases, they show gradual warming of the Earth and ocean surface, increases in ocean heat content and the temperature of the lower atmosphere, a rise in global sea level, retreat of sea ice and snow cover, cooling of the stratosphere, an increase in the amount of atmospheric water vapor, and changes in large-scale precipitation and pressure patterns. These and other aspects of modeled climate change are in agreement with observations. Fingerprint studies. Finally, there is extensive statistical evidence from so-called fingerprint studies. Each factor that affects climate produces a unique pattern of climate response, much as each person has a unique fingerprint. Fingerprint studies exploit these unique signatures and allow detailed comparisons of modeled and observed climate change patterns. Scientists rely on such studies to attribute observed changes in climate to a particular cause or set of causes. In the real world, the climate changes that have occurred since the start of the Industrial Revolution are due to a complex mixture of human and natural causes. The importance of each individual influence in this mixture changes over time. Of course, there are not multiple Earths, which would allow an experimenter to change one factor at a time on each Earth, thus helping to isolate different fingerprints. Therefore, climate models are used to study how individual factors affect climate. For example, a single factor or a set of factors can be varied, and the response of the modeled climate system to these individual or combined changes can thus be studied. For example, when climate model simulations of the last century include all of the major influences on climate, both human-induced and natural, they can reproduce many important features of observed climate change patterns. When human influences are removed from the model experiments, Results suggest that the surface of the Earth would actually have cooled slightly over the last 50 years. The clear message from Fingerprint Studies is that the observed warming over the last half-century cannot be explained by natural factors, and is instead caused primarily by human factors. Another fingerprint of human effects on climate has been identified by looking at a slice through the layers of the atmosphere, and studying the pattern of temperature changes from the surface up through the stratosphere. The earliest fingerprint work focused on changes in surface and atmospheric temperature. Scientists then applied fingerprint methods to a whole range of climate variables, identifying human-caused climate signals in the heat content of the oceans, the height of the troposphere, the geographical patterns of precipitation, drought, surface pressure, and the runoff from major river basins. Studies published after the appearance of the IPCC Fourth Assessment Report in 2007 have also found human fingerprints in the increased levels of atmospheric moisture, in the decline of Arctic sea ice extent, and in the patterns of changes in Arctic and Antarctic surface temperatures. The message from this entire body of work is that the climate system is telling a consistent story of increasingly dominant human influence. The changes in temperature, ice extent, moisture, and circulation patterns fit together in a physically consistent way, like pieces in a complex puzzle. Increasingly, this type of fingerprint work is shifting its emphasis. As noted, clear and compelling scientific evidence supports the case for a pronounced human influence on global climate. Much of the recent attention is now on climate changes at continental and regional scales, and on variables that can have large impacts on societies. For example, scientists have established causal links between human activities and the changes in snowpack, maximum and minimum temperature, and the seasonal timing of runoff over mountainous regions of the western United States. Human activity is likely to have made substantial contribution to ocean surface temperature changes in hurricane formation regions. Researchers are also looking beyond the physical climate system, and are beginning to tie changes in the distribution and seasonal behavior of plant and animal species to human-caused changes in temperature and precipitation. For over a decade, one aspect of the climate change story seemed to show a significant difference between models and observations. In the tropics, all models predicted that with a rise in greenhouse gases, the troposphere would be expected to warm more rapidly than the surface. Observations from weather balloons, satellites, and surface thermometers seemed to show the opposite behavior. This issue was a stumbling block in understanding the causes of climate change. It is now largely resolved. Research showed that there were large uncertainties in the satellite and weather balloon data. When uncertainties in models and observations are properly accounted for, newer observational data sets are in agreement with climate model results. This does not mean, however, that all remaining differences between models and observations have been resolved. The observed changes in some climate variables, such as Arctic sea ice, some aspects of precipitation, and patterns of surface pressure, appear to be proceeding much more rapidly than models have projected. The reasons for these differences are not well understood. Nevertheless, the bottom-line conclusion from climate fingerprinting is that most of the observed changes studied to date are consistent with each other, and are also consistent with our scientific understanding of how the climate system would be expected to respond to the increase in heat trapping gases resulting from human activities. Extreme weather events. One of the subjects discussed in the literature is whether or not extreme weather events can be attributed to human activities. Senaviratne et al. Stated that attributing individual extreme weather events to human activities was challenging. They were, however, more confident over attributing changes in long-term trends of extreme weather. For example, Sonaviratna et al. Concluded that human activities had likely led to a warming of extreme daily minimum and maximum temperatures at the global scale. Another way of viewing the problem is to consider the effects of human-induced climate change on the probability of future extreme weather events. Stott et al., for example, considered whether or not human activities had increased the risk of severe heatwaves in Europe, like the one experienced in 2003. The conclusion was that human activities had very likely more than doubled the risk of heatwaves of this magnitude. An analogy can be made between an athlete on steroids and human-induced climate change, in the same way that an athlete's performance may increase from using steroids. Human-induced climate change increases the risk of some extreme weather events. Hansen et al. Suggested that human activities have greatly increased the risk of summertime heatwaves. According to their analysis, the land area of the Earth affected by very hot summer temperature anomalies has greatly increased over time. In the base period 1951 to 1980, these anomalies covered a few tenths of 1% of the global land area. In recent years, this has increased to around 10% of the global land area. With high confidence, Hansen et al. Attributed the 2010 Moscow and 2011 Texas heatwaves to human-induced global warming. An earlier study by Dole et al. Concluded that the 2010 Moscow heatwave was mostly due to natural weather variability. While not directly citing Dole et al., Hansen et al. Rejected this type of explanation. Hansen et al. Stated that a combination of natural weather variability and human-induced global warming was responsible for the Moscow and Texas heatwaves. Solar activity. Solar sunspot maximum occurs when the magnetic field of the Sun collapses in reverse as part of its average 11-year solar cycle. The role of the Sun in recent climate change has been looked at by climate scientists. Since 1978, output from the Sun has been measured by satellites significantly more accurately than was previously possible from the surface. These measurements indicate that the Sun's total solar irradiance has not increased since 1978, so the warming during the past 30 years cannot be directly attributed to an increase in total solar energy reaching the Earth. In the 3 decades since 1978, the combination of solar and volcanic activity probably had a slight cooling influence on the climate. Climate models have been used to examine the role of the Sun in recent climate change. Models are unable to reproduce the rapid warming observed in recent decades when they only take into account variations in total solar irradiance and volcanic activity. Models are, however, able to simulate the observed 20th century changes in temperature when they include all of the most important external forcings, including human influences and natural forcings. As has already been stated, Hagel et al. Concluded that greenhouse gas forcing had very likely caused most of the observed global warming since the mid-20th century. In making this conclusion, Hagel et al. Allowed for the possibility that climate models had been underestimated the effect of solar forcing. The role of solar activity in climate change has also been calculated over longer time periods using proxy datasets, such as tree rings. Models indicate that solar and volcanic forcings can explain periods of relative warmth and cold between A.D. 1000 and 1900, but human-induced forcings are needed to reproduce the late 20th century warming. Another line of evidence against the Sun having caused recent climate change comes from looking at how temperatures at different levels in the Earth's atmosphere have changed. Models and observations show that greenhouse gas results in warming of the lower atmosphere at the surface but cooling of the upper atmosphere. Depletion of the ozone layer by chemical refrigeration refrigerants has also resulted in a cooling effect in the stratosphere. If the Sun was responsible for observed warming of the troposphere at the surface and warming at the top of the stratosphere would be expected as increased solar activity would replenish ozone and oxides of nitrogen. The stratosphere has a reverse temperature gradient than the troposphere, so as the temperature of the troposphere cools with altitude, the stratosphere rises with altitude. Hadley cells are the mechanism by which equatorial-generated ozone in the tropics is moved poleward. Global climate models suggest that climate change may widen the Hadley cells and push the jet stream northward, thereby expanding the tropics region, and resulting in warmer, drier conditions in those areas overall.